This video is going to cover Section 3.3 regarding exponential and logarithmic functions, and targets 3.1 and 3.2. Now this is also going to cover a little bit of Section 3.2 regarding exponential properties. Your first page of your notes should all be review from Algebra 2. So one place that you can find it is on pages 18 to 19 of your textbook, or if you go onto the Moodle page, on the far left side it says textbook and then it says chapter P. If you go to pages 19 to 20, you will find those properties online, and that's where I would like you to fill them in and do the examples on your own. However, there is one property that is not in on those pages, and that's the very last one where it says roots as powers. I just want to show you that you can rewrite any type of root as a power. So if you have the mth root of x to the nth power, you could rewrite that. Order doesn't matter. You can either do the root and then the power, or the power then the root. But if I wanted to write that as an exponent, I could rewrite it to a fraction. And you'll note that it's x to the n over m power. And so if n was 2, that would be on top, and then if m was like the third root, that would be on the bottom. So the example that I have is the third root, or the cube root, of x to the fourth. This could be rewritten as x to the 4/3 power. So this is a fractional exponent, so roots as powers. So if you go to the next page of your notes, it's talking about inverse properties of logarithms. Now, a logarithm is the inverse of an exponential function. So if you have x up in the exponent, the way to bring it down would be to apply a logarithm. So the inverse property would be if you had log base b of b to the x, that's simply just x. Because if you have log base b and you have b to the x, the log base b and the b cancel out and you're just left with the x. So logarithms and exponentials simplify and cancel one another out. The other one is if you have the base b to the power of log base b of x, then you're just left with x. So we have two examples here. Log base 4 of 4 to the 5th. This is pretty much saying 4 to what power gives you 4 to the 5th? Well, your answer would be 5. 6 to the log base 6 power of 9, you're just left with left with an answer of 9. So that's how the inverse property of exponentials and logarithms work. Logarithmic and exponential forms. Now you should be able to change back and forth from a logarithmic form and to an exponential form and vice versa. So whatever the base is, that's what you want to do to both sides. So on this one it says change from log to exponential form. What we're going to do is exponentiate both sides, meaning make both sides the exponent. So that means the left side is going to become b to the x, and then the right side is going to be b to the log base b of y. And now using that inverse property, I'm going to cancel out that right side, so I'm just left with b to the x equals y. So I'm going to do two examples. I'm going to leave the other two for you to do. So our first example is 2 equals log base 5 of x. It says change to exponential form. Well, what I'm going to do is exponentiate both sides. The base of the logarithm is 5, so that's what I'm going to make the base when I exponentiate. So then I have 5 squared equals 5 to the log base 5 of x. Now the right side is inverses, so those cancel out, and I'm just left with 5 squared equals x. On the right side, I have 3 equals log base b of 64. Exponentiate both sides. The base is b, so then that becomes b cubed equals b to the log base b of 64. Cancel out that right side, so I'm left with b cubed equals 64. Now go ahead and try example 3 and 4 on your own. I will go over these in class tomorrow. Going the other way from exponential to logarithmic form, now what I'm going to do is apply a logarithm to both sides. It's not multiply both sides, it means apply a logarithm. So log base b of b to the x equals log base b of y. So whatever that base is with the exponent, that's the log base that you're going to use. The left side is going to cancel out, so I'm just left with x equals log base b of y. I'm going to do two examples, and then the other two I will leave for you to do on your own. So we're going to change this 12 squared equals x. We're not solving for x. I just want you to change it to logarithmic form. So I'm going to apply log base 12 to both sides, and then simplify. So log base 12 of 12 squared equals log base 12 of x. The log base 12 and 12 squared, the 12 part cancel out, so I'm just left with the exponent is 2. 2 equals log base 12 of x. On the right side, we have b cubed equals 8. I'm going to apply a logarithm base b to both sides. Log base b of b cubed equals log base b of 8. The log base b and b cancel out, so you're just left with 3 equals log base b of 8. And so then you try example 3 and example 4, and I will go over those in class tomorrow. Evaluating logarithms. If you're given an expression log base 2 of 16 and it's asking you to evaluate that, there's a question that it is asking, and it's asking you 2 to what power gives 16. And so then to evaluate the expression log base 2 of 16, I know that 2 to the 4th is 16, so my answer is 4. Log base 3 of 9. The question that you need to ask yourself is 3 to what power gives 9? So that answer is 2. And then the last one, log base 25 of 5. 25 to what power gives 5? Now be careful which way it's asking. So since the base is 25, we're asking 25 to what power gives you 5? Well, the square root of 25 is 5, and the square root is the same thing as the 1/2 power. So log base 25 of 5 equals 1/2. So evaluate these three functions. Log base 100 equals what? Log base 9 of 1/9 equals what? And log base 36 of 6 equals what? So remember to ask yourself, this is saying when there isn't a base with a log, that's base 10. That's known as the common logarithm. That's what your calculator has. So 10 to what power is 100? The answer is 2. In B, it's asking 9 to what power gives you 1/9. Now there's a special type of exponent, if you were to fill out your exponential properties on the first page, that gives us the reciprocal, and that would be a negative exponent. So in this case it would be -1. If this was log base 9 of 1 over 81, then this would be -2. Then the last one that we have, log base 36 of 6. Remember the square root of 36 is 6, so that means the 1/2 power is your answer. Logarithmic properties. The first one that we have is called the product rule. If you have log base b of a product, so m times n, that's going to be the same thing as adding the two separate logarithms, so log base b of m plus log base b of n. So let's do one example together. If I have log base 4 of 7 times 5, I can change that to be log base 4 of 7 plus log base 4 of 5. Now I'm not asking you to evaluate these, you don't have to do anything further with those. The next part I have is this is base 10 of 10x. So use the product rule, same pattern as I did in example 1, and we will go over example 2 in class. The quotient rule, log base b of m divided by n can be separated with a subtraction sign. So if we have log base 7 of 19 over x, that's going to be the same thing as log base 7 of 19 minus log base 7 of x. These are used sometimes to split up logarithms if you can evaluate them separately. So it's used to simplify. It's also used to expand and condense. So try example 2 on your own, and we will go over that in class. Then the last logarithmic property that you need to know is the power rule. So if you have log base b of m to any power, that power can be brought out front and used to multiply. So then log base b of m to the p power equals p times log base b of m. So if I have log base 5 of 7 to the 4th, I can bring that 4th out front and then just do log base 5 of 7. Now these you can't evaluate by hand, but some of the examples that we do in class you will be able to. So try example 2 on your own. So we use these properties to do what we call expanding and condensing. So we're going to expand this logarithmic expression using the product rule. So I have a product, x squared times the square root of y, inside this log base b. So I can separate that to be log base b of x squared plus log base b, and then you'll notice I changed my square root of y to the 1/2 power, and I did that because I want to expand this one step further using the power rule, and those exponents can come out in front. So 2 log base b of x plus 1/2 log base b of y. And then the second one I've started for you, I have not finished. So log base 6 of this quotient, the cube root of x over 36y to the 4th, can be separated as this long expression here. Now try and evaluate this one on your own. Remember, log base 6 of 36 is asking you 6 to what power is 36. So see if you can finish this one on your own and also apply the power rule. Then the last thing that we use those properties for is to condense logarithmic expressions. So if I have log base 4 of 2 plus log base 4 of 32 equals log base 4 of 2 times 32, because I don't know 4 to the what power would be 2, this would be the 1/2, and then 4 to what power is 32, that one isn't going to be a whole number. So I want to combine these so that I can evaluate it. So then I get log base 4 of 64, and now I know that this is asking 4 to what power is 64. Well, my answer is just going to be 3 because I know 4 cubed is 64. The second example, log base 10 in this case, of 4x minus 3 minus log of x. Now this 4x minus 3 can't be separated, but the subtraction between the two logs makes it a quotient. So then I'm left with log of 4x minus 3 divided by x. The natural logarithm. There is a number called e. E is called the natural base, and it's approximately 2.71826. There is an e button on your calculator. Log base e of x is going to be the same thing as the ln of x. So you have an ln button on your calculator. We'll be using that quite a bit when we get to application problems, because e is used in the majority of exponential functions that occur in realistic situations. So e and ln are inverses of one another. So if we have ln of e to the x equals x, because ln and e are inverses, they cancel one another out. Or we can do e to the ln of x, and those cancel out, and we are just left with x. Change of base property. So if this is log base b of a, and base b is either not 10 or not e. So if it's base 3, 7, 5, 6, in order to evaluate it, we need to change the base to either 10 or e, so that we can use our calculator to evaluate it. So change of base formula would just be log of a divided by log of b. This is using the common logarithm, that's base 10. Or you can change this to natural log of a over natural log of b and get use base e. You'll get the same result no matter which log you change it to. So it says use common logs to evaluate log base 5 of 140. So log base 5 of 140 can be separated to be log of 140 divided by log of 5. Just type that into your calculator to get the result. And then if it said to use natural logarithms to evaluate, that means we're going to use the ln button. Logarithm base 7 of 2506 would just be natural log of 2506 over natural log of 7. So this video covered a little bit of section 3.2 and 3.3, targets 3.1 and 3.2, that you can apply exponential and logarithmic properties to simplify expressions, and that you can also transform exponential expressions to log form and vice versa.